All right, guys, still looking at lesson 9.4. This is task 2. Solve linear systems by multiplying first. All right, so solve a linear system by multiplying. First, you need to look at the system and determine which coefficient or what you need to multiply by based on your coefficients. So we have negative 2x and a 5x. So we know those are both multiples of 10. So we can multiply each equation by what we need to make it 10 and negative 10. Or if we wanted to look at the y's, we've got 3y and 4y. Both of those are multiples of 12, and we could multiply to get 12 and negative 12. So it looks like here it says rewrite both equations in the system by multiplying. They chose to eliminate the x's. Like I said, both of these are multiples of 10. So they multiplied the whole first equation by 5 and the whole second equation by 2. And that way they've got negative 10 and 10. And now when they add these equations together, it eliminates. And that leaves only one variable, which is then easy to solve for. All right, so how do you choose what numbers to multiply by for each equation? Choose numbers that result in both equations having the same constant number at the end. No, we're not concerned about the constant term. Choose numbers so that adding or subtracting the equations eliminates a variable. That sounds accurate because that's what we want, is to eliminate a variable. And then the last one says choose numbers so that the coefficient of the x term in one equation is equal to the coefficient of the y term in the other equation. Well, we don't care if the x and the y coefficients are the same, so the only answer that makes sense is the middle one there. All right, so it says use addition to eliminate one of the variables. All right, so this is the same equation as above after they multiplied to get the same x term, or the same constants for x. So when you add these together, these eliminate, and then 15 plus 8 gives you 23. Y, and then 35 plus 34 gives you 69. Divide both sides by 23, and y equals 3. Select the words to complete the explanation. Why do you use addition and not subtraction to eliminate a variable in this system? Well, we used addition because these have opposite signs, and that way they eliminate when you add them together. So they have opposite signs, so that you would use addition to eliminate. If the coefficients were the same, you could use subtraction to eliminate a variable. All right, solve for the other unknown variable by substituting into one of the original equations. All right, so we substitute the 3 into this equation and then solve. When you solve, you get x equals 1. Once we have our x and our y, so we got the y up here, y equals 3, and we got x here equals 1. So x, y, your ordered pair, 1, 3 is your solution. Why is the solution written as an ordered pair? Because this is 2 lines and the ordered pair is a solution, or it's the point of intersection on those 2 lines. So it is the solution of a linear system in 2 variables, x and y, which can be represented as the point where 2 lines intersect. All right, check the solution by substituting into both equations. All right, so they are substituting the x and the y into the first equation here, and you get 7 equals 7. That's a true statement, so that means it works. And then you also have to check it in the second equation. So they substituted 1 and 3 again, and they got 17 equals 17, which again is a true statement. So since the ordered pair works for both equations in the system, the ordered pair is a solution to the system. All right, so what is another way to check your solution? Graph the 2 equations and see if their intersection point is a match. That's true. Use substitution to see if the answer is the same. We could use substitution. We did that earlier. Substitute 1 for y and 3 for x. They've got these backwards. If it said 1 for x and 3 for y, that one would be true also, but they got the variables mixed up. So only that one is true. All right, that's all for task 2. If you have any questions, let me know. All right, lesson 9.4, task 3. Apply systems of linear equations. Carl drives a delivery truck. Each month he drives the same 2 routes, but not the same number of times each month. What is the length of each route? All right, so here in the truck, it kind of shows you in January, he did route A 7 times, and in February, he did route A 11 times. And in January, route B, he did 13 times, and route B in February, he drove 5 times. And the total miles for A and B in January was 636 miles, and the total miles in February was 552. All right, it says write a verbal model for the situation for each month. All right, so 7x, so here in January, 7x plus 13y, 13, y is your route B, equals 636 miles. February, we've got 11x plus 5y equals 552 miles. All right, so all they did was take the information above and write that as a system. Why do you use the same variables in both equations? Select all that apply. All right, so the total number of miles driven does not change from month to month. Well, that's not true because these 2 months, the total number of miles did change. The length of route A does not change from month to month. Okay, so that's true. Up here it does say each month he drives the same 2 routes, but not the same number of times. Okay, so the distance to one place doesn't change. Like if I drive to Walmart and back, that doesn't change how the distance unless I go a different way. All right, so the number of times Carl drives route A does not change. It did change because he drove a different amount in February than he drove in January. All right, the length of route B does not change from month to month. That's true. And the number of times Carl drives route B does not change. So that's not true because, again, he drove a different number of times in February than January. All right, so it says multiply each equation in the system. So they looked at the first term and they got 7 and 11, and they know both of those are multiples of 77. So they multiplied the top equation by 11 to make this 77. And they multiplied the bottom equation by 7 so that that is also 77. Now, I probably would have multiplied by -7 because I'd rather add than subtract. Just easier not to lose a sign. But either way, you're going to have to do a negative at some point. All right, so since these are the same, now they're going to subtract one equation from the other. So right here's where you don't want to lose the negative. So you have to distribute this negative all the way across to each term, even on the right side of the equation. Okay? So when you do that, the first x's cancel, and then 143 and 35 give me 108, and then you've got 6,996 minus 3,864, which gives you the 3132. Then divide both sides by 108, y equals 29. Once you find y, plug it into either equation and solve for x. X is 37. All right, could you have used the other equation to solve for x? Yes, you can plug it into either equation. Once you have one of them solved for, it doesn't matter. All right, so substitute 29 in for y. All right, so we've got 11x plus 5y equals 552. So we're just going to simply put 29 in here. And then once I do that, 29 times 5 is 145. And then I'm going to subtract 145 from 552. So that leaves just 11x on this side, and 552 minus 145 is 407. And if I divide both sides by 11, I get 37. All right. All right, so that means the solution is 3729. So that means route A is 37 miles long and route B is 29 miles long. Okay, so that answers the question that we started with up here. What is the length of each route? Okay, the length of each route is route A 37, route B is 29 miles. If you have any questions, please let me know.